And hello, welcome everyone again. So today we're gonna talk about a little bit more about meshing. And as you can see, I have added a little bit of a boundary layer to this piping. Of course, this piping is a little bit modified because this piping is a little bit modified. Reason is, well, I actually fixed the little problem there I was talking about in the last video. And of course, I actually took the liberty of increasing the diameter of the inlet and outlet pipes. Okay, so this is the shape I did in FreeCAD, and I export it again. The reason I prefer, FreeCAD is very convenient. So, reason I prefer the FreeCAD way of doing things is because of the sketching tools available. Okay, but you can construct shapes in Salome, there's no problem with that, but I'm not going to go through that. I'm stuck with the FreeCAD way. I prefer the FreeCAD way. So I select this whole heat exchanger, and I can export this as a step file. I call this the heat exchanger improved, and then I import it into Salome. Okay, and this is here. I selected my faces again as I did in the last few videos, and basically I did the meshing from scratch. So let me go through the meshing. I show you how you can get boundary layers as well. Alright, so yeah, apparently the reason why there were 5 million points last time round, or points in excess of several millions, is because of that stupid thingy. No, not stupid. Because of that little mistake I had in the center, where I had this little hole or cylinder over there which wasn't supposed to be there, because of a mistake in the FreeCAD sketch. So I quickly redid that. Anyway, so I'll delete this and I will start from scratch this this meshing exercise, and we can get it done from there, get things going from there. Alright, so let me start from scratch. Let's go to geometry. I'm going to, of course, delete everything that's not relevant. Delete, yes. Okay, I'm going to delete. So I want to start by importing my step file. Again, the heat exchanger improved, and I'm not going to take into the millimeter thing. Okay, so this is how I do it here. Excuse me. Now, so this is how I do it here. Then I'll quickly make the shapes again. I'll call it the inlet, outlet, and tubing. So let me zoom in, and I can pan as well. So this will be my inlet, the other side will be the outlet, the rest will be something I call tubing. Alright, so new entity, or rather, since my OpenFOAM case has already let's see the boundaries here. VRU, okay, I have tubing, outlet hemisphere, and inlet hemisphere, so I will go with that naming convention. Alright, so I'll make a few more faces. Okay, so alright, I want a new entity. Okay, new entity, new group. I'll go create a group, and I'll make the new face. So new entity, create new face, inlet. Oops, I need to select this part. Oh, main shape I need to select first. So I click on this whole heat exchanger, and now I'll click this button here. Alright. Oh man, what happened? Here please, yes, okay, good. Now then I can select my shapes, and I'll add this 74 as inlet. I will apply. Then I'll have this, I'll add, and this will become my inlet. How do I spell the hemisphere? Is it with a capital or without? It says inlet hemisphere capital. Okay, let's do that. Oopsie. Inlet hemisphere, the capital letter. Alright. Oopsie. Excuse me. inlet hemisphere. Okay, I'll apply this, and this will become my outlet. Add, apply. Okay, outlet hemisphere. Okay, 1 and 2. Apply. Then the rest will be the tubing. So I will just click select all. Okay, tubing will be here, and I will click this face to and this face remove, this face remove, this face remove, and I'll go to the other side. This one remove, this one remove, this one remove. Okay, and I will apply. So basically I have all my faces here. Alright, I have all my faces here. Let's check whether it's right. Okay, so let me hide show only the tubing. Show only, and see the tubing is as follows. Okay, it will be as follows. You can see that there's no more any such little thing in the center that will disrupt any of our meshing process or give us the wrong shape. Then let me show you the outlet hemisphere, which will be this part. Okay, and then I'll show the inlet hemisphere, which is here. Oops, okay, I should show the outlet. Okay, then my inlet hemisphere and outlet hemisphere, I just do this to show only. I'll show with the tubing and inlet and outlet. Okay, so this is our shape. Okay, since we are more or less satisfied, the rest we can start working with the mesh. And the mesh is actually pretty easy this time round. So go to mesh and create mesh from the whole heat exchanger. Mesh type, I will have tetrahedral. Now because the shape is correct, so easy, I can just use the automatic hypothesis, and I'll press apply. Okay, and that will, okay, that I can show. Well, where's my mesh? Alright, the mesh one is here, yes. So this is compute, it will compute really quickly this time because I don't have that wrong shape in the center. And look at this, I have 20,000 or 26,000 volumes, and the shape, the tetrahedral shape is there nicely. Okay, the groups of faces are here. Okay, the inlet hemisphere, inlet, outlet, blah blah blah, and tubing. Alright, but now I want, let's say before exporting, I mean I can export now and run it in OpenFOAM, no problem. But let's say I want to add some finishing touches, right? I wanted that boundary layer. Okay, so let's add boundary layer. Okay, we can go to mesh and we mesh one, and then we will edit mesh, or we can edit this hypothesis here. Excuse me. Okay, we edit mesh from mesh one. Let's call it the full heat exchanger with boundary layer. Okay, geometry is whole heat exchanger, mesh type any. Now with tetrahedral mesh or any kind of mesh, you can just add boundary layers. So you can go to this thing called add hypothesis. Okay, you see this thing called add hypothesis? Go to the gear icon and it will tell you you can add viscous layers if you want. So you can add viscous layers. This is where you add boundary layers, and this is how you construct your boundary layers. So let's do a 3 mm layer. Total thickness will be 3 mm. 3 mm. Number of layers, let's just put 3. Stretch factor 1.2. Okay. So this will be the boundary layer settings, and it's much easier to do than snapping X mesh. Okay. So we can specify how we want the boundary layers to grow off the walls. Now my personal preference is surface offset and smooth. That seems to be one of the easiest ways to deal with complicated shapes. Then let's specify only, then you can specify the walls. So you can use faces with layers for the walls, or faces without layers for inlet and outlet. Okay. And what you can do is just to select, for example, under your geometry, you can select inlet. Alright, you can select inlet and you add under your geometry, yeah, not inside your mesh. You have to do it under your geometry, under whole heat exchanger. I can select the inlet and I can also select the outlet. Okay, so once we are done with that, I can just click OK. So I have a 3mm layer in the hypothesis. So let me go to mesh 1. I'll edit the mesh, and under edit mesh I can, under the add hypothesis, instead of just 1D, 2D, 3D and all, I can add a 3D layer, 3mm layer, excuse me, and I'll just click apply, and now I can just recompute. So it will again go through really quickly, because that's how it was supposed to go. And as you can see now, my layers are added. The first layers are of course thinner than the layers outside. You can adjust it later on. You can see it's pretty easy. And I'll just call this mesh whole heat exchange. Okay, heat exchanger with boundary layer. Okay, heat exchanger BL. So this I can then export to UMV. Export to UMV, heat exchanger boundary layer, sure. And let me go to my salome directory. Let me go to my salome directory, my salome work directory, and I will just copy this over. I'll copy this over to GitHub, the thin pipe flow snappy X mesh, and here it is. I can go to heat exchanger salome. I'll just delete this OUMV file. Okay, OUMV file, I'll delete it off, and I will paste the new file here. Now of course I can start opening this in terminal. Okay, so we can open this in terminal in the heat exchanger salome, and we do the IDS UMV to foam. We run it on the heat exchanger boundary layer UMV, and you can see it's very quickly done. The mesh has been generated, and we can test. We can look at this in what do you call it? We can look at this in this what, ParaView. Yes, my goodness, how did I forget? ParaView. Okay, so this is what it looks like, and then we can just add the filter slice plot. We can do a Y normal. Okay, and we can do surface with edges, remove the plane, and you can see that the boundary layers are nicely added. Of course, excuse me, these are tetrahedral meshes. So when you do cross section of tetrahedral mesh, this is what it looks like. Doesn't look very nice, but of course you can use the crinkle slice plot, crinkle slice, to show you what the mesh elements are like. So you can see that these are the mesh elements. Of course, now we have a tetrahedral mesh. We can of course convert this into a polyhedral mesh by running poly dual mesh 75. So that's done. So let's see what the polyhedral mesh looks like. So you can see polyhedral mesh has been generated. Okay, and it should be a lot more stable, and as you know, the boundary layers are still there. The boundary layers will still be there, not an issue. Okay, of course if you just want to look at the inlet, okay, inlet, so this is what the inlet mesh will look like with the polyhedrons, and we are pretty much almost okay to start running. Okay, so this is what the polyhedral mesh will look like. Okay, should be a lot more, very stable, so okay, looks like this is actually a decent file. Okay, decent file. So I guess I can start writing a script. So I'm going to copy over FreeCAD style mesh gen, or maybe I'll just move this FreeCAD style mesh gen to salome mesh gen. Okay, I prefer polyhedral, so I'm just going to include the polyhedral part in it. Okay, salome mesh gen. So this is very easy. I'll do the all clean first, Then after that, I don't do anything of this. I'll do the transform points at the last part, because I'll need to, get this in. Okay. Then let's me yank and paste. So this is what I'll do, and I'll just use ideas UNV to foam. What is it? Ideas UNV to foam, heat exchanger BL.UNV. I'll just copy and paste this because I don't want to type everything out. Let's see. BI Salome Mesh Gen. Okay, I'll paste it here. So you can see it's capitals all here. U, T and F, UNV to foam. All these are capital letters. Alright. So let me run the Salome Mesh Gen. So it will be running very quickly. And I need to touch salome.foam. Did I see Salome Mesh Gen? Yeah, touch heat exchanger.foam. So that's good enough. I don't need a salome.foam. Go to heat exchanger.foam, open it up, and we'll see the polyhedral mesh there, and it is ready to run. Okay, so let's run pimple foam on it. It should run really quickly. And of course, we can check the dimensions of this because it sure should be in millimeters. So let's do the axis grid, and we can see that it is indeed less than 1 meter. The whole thing is about 0.4 meter, 40 cm ish. Okay, and the tubing is about 25 cm. So that's a very small heat exchanger if you think about it. Okay, but that is it. And let's try running pimple foam on it. Pimple foam. Okay, so right. There is no zero folder. Okay, so I need to copy and put the zero folder there. Let's run pimple foam. Okay, so there are a few things to more to note. I need to change the wall, the type from wall to patch, the inlet hemisphere, outlet hemisphere, and tubing, because that's what the error here is saying. I need to change that to, oopsie. Go to create patch. So go to system, create patch dictionary. Alright. So let's do the new patch, name of new patch. I'm not going to. Okay, let's do tubing first. Tubing, patch info, I will say it's a wall patch. Construct from set, let's do this from tubing. Okay. Then let's do inlet hemisphere. Okay, construct from inlet hemisphere. And one more is the outlet hemisphere. And that has to be a wall patch, and that will be constructed from outlet hemisphere. So I'm just changing the patch there. Patches were outlet hemisphere. Okay, so I need to construct from patches instead of set here, because I'm actually specifying what patch I'm supposed to get all of this from. Okay, so let's do a create patch and see whether I run into any errors. Okay, create patch, override. Okay, create patch override. Alright, so what I need to do is to put this into my salome mesh gen script. Okay, create patch override. Okay, so let's try running pimple foam again. Okay, inlet hemisphere must be wall, current type is patch. Alright, whatever. I'm gonna sort this out like off-site, and but as you can see, I could not finish this, but as you can see, I show you how to do polyhedral meshing, and of course also I showed you how to add boundary layers in Salome. So thanks for watching. I'll see you guys again. Bye bye.